Good morning. Good morning. All right. So today we're going to be talking about outliers, right? Outliers, and I want to be able to look at them from multiple perspectives. And what I'm going to do is this: you won't see a normal worksheet attached like I normally do. Instead, what I decided to do is make a Google form for you to be able to complete two questions, just to allow you to see if you watch the video and you're able to complete it. I might go with this style for the rest of the year. We'll see where you don't have to actually print out my worksheet and try to complete it and then upload it. Instead, I'll create a worksheet on Google Forms for you to have to fill in. And then from there, once you submit it on Google Forms, it can easily quickly grade it for you. You can see what you got wrong, you see what you got right. Majority will be multiple choice, but I'm just trying out some new stuff as we go. Also, I was thinking about with my brother yesterday, different incentives. So if you are logging in regularly or completing worksheets in a certain amount of time, possible we made some suggestions about pizza or gift cards, something like that for me to be able to send out to you guys. So that's in my mind thinking, and I'll get back to you as to possibly what we could do just to encourage you guys to keep logging in and to continue to do the best work you could, okay? All right, so let's dive into what we're doing today. I'm going to share my screen with you. Like I said, we're going to be talking about understanding outliers. And an outlier is a way where we observe the data that we're given and we see that something lies outside of the overall pattern of the data. So if there are some points or data points that lie outside of the overall pattern or the majority of the data, they might likely be called outliers. Now, there are specific ways to calculate outliers. We're going to talk about that after we calculate IQRs this week. I want you to be able to take a visual representation and understand visually what an outlier looks like. So let's look at that first. So visually, if you look at this, if you look here, this is the actual histogram that we have here. This histogram, or it's a histogram, not a bar graph, but it looks like a bar graph, right? You can see that this number that's all the way down here, right? This like bar here, that's an outlier. Now, why is an outlier? Because all the rest of the data is over here. However, this bar is all over there by itself. It's outside of the normal observation of the data. Now, if you look at this dot plot, right, which we're going to be focusing on dot plots today. If you look at dot plots, you'll see the majority of the data is all over here underneath 40. And then all of a sudden you have one at 75 and one at 85. Those 2 points there are called outliers. Now, why this is significant? Why? Because you'll see that you can have more than one outlier, which is important for you to get today. It's not just one number that could be an outlier. There could be more than one. There could be four. There could be three. There could be two. It could be a certain amount of outliers. But you look at the generic data and you see, okay, well, are there any that actually lies outside of the actual cluster that I see? And we're just doing observations at this point. But what I would love to do is what we're going to do in lesson 9.4 after we learn IQR, we're going to talk about how to represent data on a box plot and identify the outlier from the box plot, which looks like this, right? So after you create your dot plot, right, which you see, there's some outliers here. Now, this is not your custom way of creating a dot plot because a box plot, because here you need to know the IQR. You need to know the interquartile range in order to determine what numbers actually are really outside of the generic strand of data. Okay, so that being the case, what I want us to do is focus solely on right now creating dot plots and identifying the outliers from there. Okay, and then you'll complete the actual two questions that are on the Google Forms, and that'll be your submission of the assignment for today. So you just got to watch this video, let me explain it, and then you do two questions on your own on a Google Form sheet. Okay, so let's say you're given something like this. This is a modeling example. It says write the outliers for the set of data. Now, if you can look at me, you see that there's data here, 92, 88, 106, so on, so on, so on. Now, there are some numbers that may stick out to you. You may see 59, you may see 106, you may see 169, you may see 10, you may see all these weird data points in there. And it tells me that the data is very spread out here. It tells me the data is very spread out. It's not clustered together, right? So my first suggestion, if I was trying to give you a step-by-step guide as to how do we complete this and how do we do it with well, the first step I would have to tell you is this. Step one would be to rewrite the data. So rewrite the data from smallest to largest, right? And we are already accustomed to this. And why are we accustomed to it? Because we have done this when we calculate the median, when we calculate the mean, or when we calculate different points of data, mode, all those different types of styles. So when we see data that are given us like this, the first thing we should be encouraged to do is to rewrite data from smallest to largest, because we use that even when we're dealing with dot plots, even when we're dealing with box plots, right? So the first step would always be to rewrite this data, okay, from smallest to largest. Okay, after you have done that, right, and after you have done that, matter of fact, let me do that with you right now. So I want to write that with you now, and what I believe the actual numbers should be. And I'm just going to write them over here to the side in another box, and I'm going to write them in red, so that way we can all be looking at the same exact numbers. When I look at the numbers that I'm given over there, I would see, okay, well, I have 10. 10 is the smallest, right? 10 is the smallest number that we have. The next number coming up is 59. Then it's 67, 72, 73, 76, 88, 92, 106, 111, 115, and finally 169. Now keep in mind, obviously I already done this already on my own, on my notes, so I'm just looking there. I'm not really looking at the numbers. But what I would encourage you to do, and this is actually how I did it when I actually wrote it, is I would say, okay, 10, right? So I would go, okay, I need 10, and once I got 10, I would cross it out. Boom, cross out 10. 59, cross it out. 67, cross it out. And I would keep writing them as I put them in order, and I would go through each one and just cross them out. Now, after I'm done rewriting my numbers, I'm going to count how many I have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 numbers here. Make sure there are 12 numbers in the original as well. So 3, 6, 9, 12. Perfect. So they both have 12 sets of numbers. That means I didn't miss a data point, and I wrote them from smallest to largest. That's your first step. Now, the second step, right? Our second step that we should be doing, sorry, hold up. Okay. The second step would be for us to, after we rewrote the data, now we need to be able to create a visual representation. So we want a visual representation here, right? And when I say visual representation, I don't want you to think about creating a box plot, because I told you this, the box plot visual representation, you need to know something called an IQR, and I haven't told you that yet. I haven't taught you how to do it yet. So when I talk about visual representation here, let's focus solely on dot plots, because we've done dot plots, and they are not as they're not as confusing as box plots. You don't need all 5 data points to do a dot plot. You just need to dot them, right? So create a dot plot, right? After you create a dot plot, the third step is you're going to look for data. And I'm going to write third step here, and I'm going to show you what my dot plot looks like. Step 3 would be to look for data outside of the normal distribution. And I know that sounds weird, but this is a very popular word when it comes to statistics and analyzing data. How is the data distributed? How is it separated, right? So if you see a cluster of data over here, and all of a sudden there's one point over there, that point over there might likely be your outlier. Outlier. All the rest of the data is here. All of a sudden this point is all over there by itself. That means it's all over there by itself. It's an outlier. It sticks out by itself. Okay? So let me show you what my dot plot looks like for this particular modeling problem. Okay? It looks something like this. I'm sorry, hold on. Okay. I'm going to move these steps because I still want them to be here. The numbers is fine. I can keep those right there. But you'll notice here that I put my dots here. This is important that you also know I created a number line. My number line was not solely on the numbers that they gave me. It had to cover all the numbers in between. So I went from 5 all the way to 170. Okay, this is important. I didn't just write numbers 92, 88, 106 and just kept those numbers. I made sure I created a number line that had all these numbers in it, but not only these numbers. Okay, so I went from 5 to 170, and I made dots at each point that I seen that was here. Okay, this is important because a good amount of times, right, you'll be given about 9 numbers, right? But the number, if they're really well spread out, you can't just put 9 slashes on a number line and put those numbers in. You do need to show me that you understand, one, how to count on a number line, and two, also that you could be able to represent the dots and make a good interval with the number line. So notice here, my number line is not 5, 6, 7, 8, 9, 10, 11, 12, right? My number line, I skipped by 5s. Why did I do 5s? Because I knew my lowest one was 10. My highest one is 169. So the only way I can really cover all that data, now could I went by 10s? Yes, but then I would have had a hard time finding like 92 or 87 or 88 rather, right? So you want to make sure you kind of distribute it well when you create your number line as well. So I went by 5s. I put my dots in, and if you notice something here, and I'm going to circle them in a different color, right? Let me use green. You'll notice this is the cluster of my data right here. This is the cluster of my data. All my data is really right there. However, there are 2 points, just 2, that are outside that data. One here and one here. When they are outside of the generic form of our data, this is known as our outliers. These are known as our outliers. So I would write here, just so we all know that, right, this is an outlier, and this one over here is also an outlier, okay? These are our outliers of the data, right? So if I was writing my answer, I would say my outliers are 10 and 169, right? You could have probably guessed that just by looking at the numbers itself, but you want to make sure the cluster. Now, in most cases, your outliers are going to always be the last 2 when you write them from smallest to largest. Do you see that? When you wrote them from smallest to largest, you've seen that the smallest here is an outlier and the largest here is an outlier, right? Is it always like that, Mr. Orford? No, it's not, okay? Because it may be in a situation where all the numbers are small and all of a sudden you have 3 that are really big and out of this world and they're the outliers, right? But you want to look toward the ends to say, okay, are those really far out, okay, of my data? All right, so this is how you do it. I'm going to do one more example with you, but let me recap the steps and then you can copy down notes if you need to. I would suggest you have a pen or paper, just to have a pen and paper with you on the side. I know I'm not giving you an actual worksheet to print out on this particular side, but you do have to answer 2 questions on the Google Forms, okay? So let me reset. Step 1, you're gonna have to rewrite the data, smallest to largest, okay? After you write it from smallest to largest, think about representing it as a visual representation of a dot plot. Number line, and put dots where each one of the numbers fall, okay? Look at it visually. See what the cluster of data is that is really the normal distribution, and then see what lies further outside of that, okay? And as you can see here, there are 2 that lie further outside. This is a visual, right? Visually, you can see it here, and we'll deal with the actual calculations on 9.4, all right? I'm gonna clear the text. I'm gonna do one more example with you. If you have any questions, as always, you can leave them underneath the video. So let me do one more with you. I'm clearing it right now. Let me go on to the second example. Now, once again, they tell me to write the outliers for this set of data. I see that I have 9 data points here. My first step, as we talked about last example, was to write them from smallest to largest, okay? So when I write these numbers from smallest to largest, right, I'm going to write them right underneath it. Let me write them in red. I get 52, 65, 67, 69, 71 2 times, 73, 79, and finally 94. Okay, these are our data. If I was to write the data, right, from smallest to largest, this is what we end up getting. Okay, now I need to create a number line. That's the second thing. I need to, after I write it from smallest to largest, now I need a visual representation. I want to visually represent this data via dot plots, not box plots, dot plots. So I want to write a number line. Now notice my smallest is 52, my highest is 94. So I might want to go from 50 to 96, right? And because I know those are even numbers, both of those at the end, I might want to use going by twos. I want to go by twos here. And I see the data is a little more closer together than the last example. So I'm going to go by twos here and I'm going to create it. And it's going to look something like this. Oh, okay. This is my number line. I went from 50 to 94. You could have went on 96, but I went from 50 to 94. I went by twos, okay? I put my dots in the right spots where they need to be, right? And you'll see 52 is there, 65 is here, 67, 69, 271s, 73, 79, and then 94 is over there, okay? I created my number line. I put my dots in place. So that was step one, smallest to largest. Step two, visual representation. Step three, I'm looking for these outliers now. I want to find where's the normal distribution of the data. Where is that normal distribution of the data? That's my next question. I want to say, okay, well, where's the data at? Okay. If I look here, I see, wow, look, this looks like the majority of the data. But I noticed that there's these two, which is outside of that normal, right? And I'm only looking for the clusters. Well, how do you know that's the normal? Well, I'm looking for the ones that are really clustered together. And even I see right here that that one may be a little bit out. So if you want, you can stop it right here and say that one's a little bit out. But I would prefer visually for you to say, okay, looking at it visually, I see this is more closer together than those two, which is further spread out. Okay, so that would mean that this one here and this one over here are our outliers, okay? And that's how you would answer these problems, okay? So what I want you to do is there's two problems for you on a Google form that I attached to this video as well on Google Docs, on Google Classroom. Please answer those two. They're not hard, right? But you do have to follow these steps to identify what the outliers are, all right? Thank you guys so much for watching the video. If you have any questions at all, please feel free to talk to me. If you need to copy down the notes, copy. I'm about to clear it. 3, 2, gone. All right, awesome. All right, if you have any questions, feel free to reach out to me. Thank you guys so much for watching. I'll talk to you later.